T is time to reach final, P is the period, they have to be in the same unit. So if one is like minutes, the other one has to be minutes, okay? R is your rate. Now what percentage is something if it hasn't changed? If I gave you what you have and you still have it, what percentage is that? 100%, which is what is a decimal? 1. So if something doubles, what percent do you have? 200%. What would that be as a decimal? 2. If something triples, what percent would you have? 300%, and so that would be a 3. And then what if it halves? What percent would you have? 50% or 0.5, correct? Or you could use a half. So the rate depends on what you're looking for. So if it's doubling, what's this bracket going to be? Not 1, what's it going to be? 2 for 200%, correct? If it's tripling, the R is going to be 3 for 300%, and if it's a half-life, you're either going to get 0.5 or a half. All right. So let's look at example 1. The hardest part about these ones is determining what the T and the P are. So you just have to make sure you know the difference. So if it's a T, it's time to final. If it's a P, it's how long it takes to double, triple, or half. And the time often follows double, triple, or half if it's P. So let's go through this. A lab tech placed a bacterial cell. What did they give us?
Bacterial cell.
Cool. Which letter? The number is 1. Yes. Which letter? Initial. So capital I equals 1. Lab tech placed a bacterial cell into a violet 5-band. The cells divide in such a way that the number of cells doubles. What does that give me?
Rate.
What is your R? 2 for 200%, right? Because it's doubling. Doubles every 4 minutes. So in 4 minutes, I'm going to have 2. And then in 4 more minutes, I'm going to have 4. And in 4 more minutes, I'm going to have 8. In 4 more minutes, I'm going to have 16. 4 more minutes, I'm going to have 32. It's doubling every 4. So is that T, time to reach final, or P, the doubling period?
Period.
It's a period. People find it really hard to understand. T is how long it takes to get to the final amount. P is how long it takes to double, triple, or half. So if it doubles every 4 minutes, I give you P. And P and T have to be the same units. So how long does it take for the cells to divide to produce 4,096 cells? What did I give you?
Final.
Final. And what are you missing?
Time to reach.
So which letter?
T.
Time to reach final. So let's fill in what we know. We know 4,096 equals 1, 2 to the T over 4. Now my T is going to be in minutes because my P is in minutes, and they have to be the same units, correct? The first thing we do whenever we do a work problem is if we know the final and we know the initial, we divide our initial over. So we're going to divide the 1 over. Doesn't do a whole heck of a lot. So 4,096 equals 2 to the T over 4. Now we talked about this on Friday. When we don't know the exponent and the exponent is in the, the variable and the variable is in the exponent, we have to convert it to a log. That is how we get that exponent to come down. Now how do we convert it to a log? The base of our exponent becomes the base of our log. So we get log base 2, because this is the base of my exponent, right? What's friends says to stay friends. So what's going to go beside it now?
4,096.
And it's going to equal T over 4. How do we get rid of a division of 4? Times it. So T equals. Everyone's trying to type it in. So remember you check your math button first, see if you have that log base button. If you have that, you're going to do that. Everyone's trying it out to see if they can get rid of it. It takes 48 minutes for the cell to divide to produce 4,096 cells, right? Okay. Now this one, what is the half-life? What did they give me?
They give you the half-life, so we know that will be R. So,
R is going to be a half or
0.5.
0.5. Plutonium-232, that's an isotope that isn't found anywhere. Okay? If in 204 minutes, that's T, because it doesn't come after doubling, tripling, or half-life. It's not like it halves in 204 minutes, or it doubles every 204 minutes, right? It's in 204 minutes, the sample decays to 1/64th of its original mass. So we have T equals 204 minutes. Now, I can make my original be anything I want, as long as my final is 1/64th, correct? So the easiest thing I can make my initial be if they don't give me one, because it's just decaying to 1/64th of the original, I can make my initial be 1, and then what's 1/64th of 1? 1/64th. If I did 100, I would have to divide it by 64 and then write that as my final, which is perfect, so I just use 1. And what are they making me look for?
P period.
P, yeah. What is the half-life? So listen, when the question, when half-life doubling or tripling is in the actual question, it's making me find P. What is the half-life? Oh, it's making me find the period. What is the doubling time? Oh, it's making me find the period. Can you try it out? Our final is 1/64 equals 1, 0.5 to the 204 over P. So I'm going to divide the 1 over, so if I have my initial and my final, I divide it over. So I get 1/64 equals 0.5 to the 204 divided by P. Then once again, I don't know the exponents. I don't know the exponent, I have to convert to a log. So I get log base 0.5, what's friends doesn't stay friends, 1/64 equals 204 over P. Now when the P's in the denominator, remember you bring the P up and multiply it, and then bring the entire log down and divide it, correct? So you bring your P up by multiplication, so it cancels off, correct? And then we take our entire log and divide it. Some people say they swap spots. They kind of do, but they kind of more so divide. So we're going to get P equals 204 divided by log 0.5, 1/64. Everyone's punching in to make sure they get the right answer. Giving 34 minutes. Then we're gonna flip over. Okay. 3, 4, 5, go. Quickly. Radioactive isotope has a half-life, which is my R. Half-life of 7 years. What's that? T or P? P. It comes right after half-life. It comes after the word doubling. It comes after the word half-life. It comes right after the word tripling. It's your P. This is a half-life of 7 years. So in every 7 years, this isotope is halving. That's its period of half-life. Okay? So T is going to be in years as well. How much of the isotope must be initially present, so they're asking for I, in order for it to decay to 60 grams, F, in 14 years. That should be an S. So we get 60 equals I bracket 0.5 to the 14 over 7. Now this is the catch. A lot of people want to convert to a log. You only convert to a log when your variables in your, I don't know, when your variables in your exponent. So, you have 60 equals I, 0.5 to the 2. How do I get I by itself? This is multiplying, so how do I do it? Divide. $240. 240 grams. And then he would write a sentence that would say, the initial, there must be initially present 240 grams of the ice, radioactive isotope. Okay, a material has an initial mass of 50 milligrams and a half-life of 20 minutes. So they come right after each other, so it's T. It halves every 20 minutes. So that's period. Determine the mass after 35 minutes. So that's time to reach final. And we don't know the final. So we get F equals 50 bracket 0.5 or the half to the T over P, 35 over 20. And then we just type it in. And you get 14.9 milligrams. Okay, and then you say the mass after 35 minutes was 14.9 milligrams. Okay. Culture starts at 3,000 bacteria, so that's my I. After 3 hours, it's estimated to be 48,000, so that's my final. Is that T or P? After 3 hours, there's 48,000 bacteria. It's your T. Because it's nowhere near the word half-life doubling or tripling, correct? It says after 3 hours, that's the time to reach final amount. So that's going to be my T. And then here it says, what is the doubling period? Remember when the word doubling, tripling, or half is in the actual question, they're often looking for P. So is the doubling period R equals 2, because it's 200%, and P equals not sure. So we get 48,000 equals 3,000, 2 to the T over P, divided by 3,000. So we get 16 equals 2 to the 3 over P. And a lot of people converted this. You'll convert it to a log, but you could actually make them both be the same base. 16 is 2 to the 4, so I'm going to do this instead of logging it. So 16 is 2 to the power of 4. It equals 2 to the 3 over P. So now I have 4 equals 3 over P. The P comes up and the 4 comes down, so I get P equals 3/4. Or 0.75 hours. If you convert it to a log, you should get the same answer. Okay? Alright, the next one is compound interest questions. Now, if you're given the compound interest question on a test, it's often accumulated amount equals principal 1 plus I to the n. They don't add the CPs, and they use accumulated amount of principal. It doesn't matter what they do. If they give you the formula, they have to tell you what stuff stands for. So, we're going to use the F formula. So, F would still be final. I is still initial. Little I is still interest rate. But it has to be in decimal, and we're always going upward. N is the number of years. And CP is the compounding period. Now compounding periods, the reason why where you want compound interest, not simple, pay attention. Where you want to have compound interest is when you are making money. So if it compounds monthly, that means at the end of each month, it's taking the interest you made and it's putting it in with what you invested. And now the next month you're making interest off of what you put in and the interest you made. And at the end of that month, it's going to take the interest and it's going to put it back into your bank account. And the next month, you're going to make interest off of what you put in and the last 2 months' interest as well. So you actually make more interest off of your interest. So if it compounds monthly, that's 12 times a year. If it compounds quarterly, it's 4. It's over there. If it compounds semi-annually, it's 2 times. And annually, it's once. So annually, at the end of the year, it takes all the interest you made, puts it in, and the next year you make interest off of that. Semi-annually, every 6 months. So 2 times a year. Quarterly is each quarter. Just 4 times a year, monthly is 12. Yeah. So it just makes you make money faster. Okay? So here we have Isla invests $500. What is that? My daughter. And she's investing, if only she was so happy. $500. What letter is that? That's a lot. She invests $500 in an account paying 6% per annum. Per annum just means per year. It will always be per year. Don't let per annum throw you off. So that's your little I. 0.06. Yeah, that's huge. And it's compounded semi-annually. So how many times a year is that? Yeah. So determine the value of the investment. So they want F after 5 years. It is 5. All right. The catch with this, compared to the increasing and decreasing or appreciating and depreciating, is your interest rate, yes, per year is 0.06. But per compounding period, what is it? 0.0. It was 6% per year, so what's it going to be every compounding period? 0.03. So we have to remember to take our interest rate and divide it by the compounding periods, correct? The other thing we have to remember is the number of years. Yes, it's 5 years, but how many times does it actually compound if it compounds twice a year? Nope. This is in for 5 years. It compounds twice a year. So how many times does it actually compound? 10. So that's why if you look up here, your interest rate is divided by compounding periods because it's per compounding period, not the whole year, correct? And your N is multiplied by compounding periods because we need to know how many times it compounds. So you can't forget the CPs even though they don't put them on the test. Okay? If they do give you the formula, sometimes they don't. So we're trying to find our final. Our initial is 500. And then we do 1 plus, what's our interest rate going to be? Not 6%, what's it going to be? 0.03. Because we have to do 0.06 divided by 2, correct? The compounding periods per year. What's our exponent going to be? 10. Because what are we doing? We're doing 5 years times 2 compounding periods, which is 10. Do we agree? Okay. So we're going to get F equals 500 bracket 1.03 to the 10. And we know we're increasing because it's 1.03 steel. Yeah, you can run. I think they run, but you asked it. So okay. So the final is 671.96. interest did Isla make? What would you do? Subtract the 500, because that's what she came into the bank with. So yes, she's leaving with 671.96, but she walked in with 500, correct? So she only made 171.96. Still good. Good money. Okay. Down here it says, how long will it take? So they want N for the investment to double. So what's our final going to be? So what's our final going to be? 4,000. She's only going in was 500.
Oh, if I say that's what 5 million all.
Okay, are we paying attention? All right. So, what is our final? Our final is 1,000. What's our initial? 500. Bracket 1 plus 0.03. That doesn't change because we're still doing. Get that? We're still doing 0.06 divided by 2, right? Same compounding periods. What's going to go up here? Close. Right. Close. And by close, I mean correct. Okay. 2n. Why did you do 2n?
It's 10 times CP.
We know CP is 2. We don't know n. Yeah, correct. Okay. When we have initial and final, our first step is always 2. Divide that initial over. So we get 2 equals 1.03 the 2n. Now this one I can't make common base because I don't know how to make 2 be 1.03 the base. So I can't make this one a common base, but what can I do? Yeah, convert to a log. So we're going to get log base what? The base of our exponent becomes base of our log. 1.03. What's friends doesn't stay friends, so what am I going to get beside it? 2, and it's going to equal 2n. And then we're going to divide by 2. You weren't wrong. Not exactly where I was going, but you were not incorrect. 11.7. Okay, so we're going to flip over. Two questions on the back. I'm going to give you about 2 to 3 minutes. Get working through them, and then we're going to start with the next thing. Yeah. Because we've done our homework in class together. So, 7,000 is invested into a 6-year GIC compounded quarterly. So our capital I is 7,000. 6-year GIC is my N. Quarterly, what's my CP? And an interest rate of 0.05 per annum, and they want F. So F equals 7,000, bracket 1 plus. Now remember, the interest rate has to be per compounding period, correct? So we're going to get this value here, we're going to go 0.05 divided by 4. Yeah, 0.125. And then, how do we get the value up here? So we do 6 times 4. So this is 24 compounding periods, correct? So then we get 7,000 bracket 1.0 to the 24, 9,431.46. Okay, 3. Determine the interest rate. So this time we want little I. 1 decimal place at which 3,000 invested, compounded quarterly, will double, so final of 6,000 in a 5-year period, and it's 5. So we're gonna get 6,000 equals 3,000. Bracket 1 plus I divided by what? 4. And then what's up here? Yeah, 4 times 5 is just 20, right? We know our initial and final will always divide it out. So we get 2 equals 1 plus I divided by 4 to the 20. What do I have to do next? Take the 20th root. Or you can raise the power of 1 over 20, but I'll take 20th root. So that's going to be a non-terminating decimal, so I'm going to leave it as 20 root 2 equals 1 plus I divided by 4. Then what do? Subtract 1. You have to do reverse bedmath to do the subtraction steps first. So 20 root 2 minus, or root 20. Oh no, 20th root of 2. Minus 1 equals I divided by 4, and then we divide by, or multiply by 4. And I equals 1 decimal place. .14105, which is 14.1%.